Let's find the arc length of f(x) equals 1/2 e to the x plus e to the negative x on 0 to 2. This problem is kind of interesting because it requires a bunch of, well, I shouldn't say tricky algebra, but a little bit of algebra that takes a little bit more thought. So let's pay close attention to what's going on here. First of all, let's find f prime of x, because one of the things we need to do is make sure that the first derivative is continuous on 0 to 2. Well, f prime of x will equal 1/2 times e to the x minus e to the negative x. Well, that is continuous on 0 to 2, because at 0, this is 1, and minus 1 over, well, let's look at this real quick. Just this piece right here, this is the same as e to the x minus 1 over e to the x. At 0, e to the 0 is 1, so this is 1 minus 1 over, well, e to the 0, 1. 1 minus 1 is 0, so yeah, there's no problems there. And there's no points of discontinuity between 0 and 2. So this is continuous on this interval, so the arc length formula will be rectifiable. We're going to have some type of finite length there. So now the s, the arc length, is going to be equal to the integral from 0 to 2 of the square root of 1 plus, now I need this whole quantity squared, 1/2 times e to the x minus e to the negative x, this whole thing squared, dx. Now, let's just take this piece. I'm going to leave the calculus for a second, and I'm just simply going to do a little bit of algebra to put this in a form that I can integrate. So I have 1 plus, if I square this, this would be 1/4 times, this would be e to the 2x minus 2 e to the x, e to the negative x, plus e to the negative 2x. So if I add these together, I need a common denominator, so this would be multiplied by 4 over 4. This whole thing will be equal to 4 plus e to the 2x minus 2e to the x, e to the negative x, plus e to the negative 2x all over 4. Now, e to the x times e to the negative x is e to the 0. That's just 1. So 1 times negative 2 is just negative 2. Now, if I add these together, I can combine these constants. This is going to be e to the 2x plus 2 times e to negative 2x all over 4. Well, see, this piece now, if I look at it as e to the x squared plus 2 plus e to the negative x squared over 4, the numerator, this is the sum of squares. This is the same as e to the x plus e to the negative x squared over 4, which is the same as e to the x plus e to the negative x, over 2 quantity squared, because that gives me my 4. Well, that's really nice, because this is what all of this is equal to. So now I can rewrite that integral. I can simply say that the arc length f is equal to the integral from 0 to 2 of the square root of e to the x plus e to the negative x over 2 squared dx. Well, the square root of something squared is just that, something. So this is equal to the integral from 0 to 2 of simply e to the x plus e to the negative x over 2, but I'm going to take that over 2 and pull that out to 1/2 dx. This is now pretty straightforward to integrate. This is going to be 1/2 times the antiderivative of e to the x is just e to the x. The antiderivative of e to the negative x is a negative e to the negative x. See, if I take the derivative, I get the double negative, which is a positive, which I start out with from there. And this will be from 0 to 2. So this I can quickly evaluate. This is going to be 1/2 times e squared minus e to the negative 2. I'll do this. Minus, evaluated at 0. At 0, this is 1 minus 1. Well, that's just 0. So my solution is simply going to be 1/2 times e squared minus e to the negative 2. Now I can fiddle around with this and change the format if I wanted to. I don't think it's going to gain me anything. I mean, obviously I could write this as 1/2 times e squared minus 1 over e squared. I could bring the 1/2, I could put the whole thing over 2, so I could write this as e squared minus 1 over e squared all over 2, which is the same as e squared minus e to the negative 2 all over 2. You know, there's 4 or 5 different ways I could write this thing, but really, I think I would stick with that because changing these forms is not doing anything for me. If it made life simpler, then, well, if you think this is more simple, then maybe you can go with it. The point is there's many different ways to write most solutions. Unless there's an advantage to changing the form, I'm going to stay right there.